Did I actually plug this in? Let's see. Yep, audio's working. All right, well, I will begin with a word of prayer here in a minute. I need to get the top hat going, so you guys have a good second week so far? Yeah. Which seemed longer, the first week or the second week? Second week seems longer? I always feel the opposite. I always feel like the first week is like forever. And then second week just kind of start to get into some sort of routine. All right, well, I think everybody's here, so I'm going to begin with a word of prayer. Heavenly Father, we thank you for this day again, Lord. I thank you for these students and for this morning. Just pray that you'd bless our work today. Help us to glorify you, Lord, in what we do this day, Lord. In your name I pray. Amen. All right. Hopefully my computer will be acknowledged by the network here. Although I seem to have lost my cursor, which is not a good sign. Oh, no. There's my cursor. It's not moving. That is a worse sign. Huh. Well. Come on. Well. Well, this is fun. My computer seems to have Yes, I would like to restart. Thank you. Haha. All right, so while we're waiting for my computer to behave, let's do some math. So I'll get straight into it here. Sorry for the delay. Example 1. Let's see if we can solve 2x minus 7 divided by x equal to x minus 2 over 5. So this is, I'll be covering examples that are related to the last 10 problems in your homework today, okay? Like problems 30 through 40. So this is roughly titled Other Equations. And, well, I mean, yeah, it's other equations, but truth be told, like a lot of these, after the dust settles, we're back to a quadratic equation again, all right? So we're going to get more practice with solving quadratic equations in the context of doing these. All right, so how do you solve this? Any ideas?
Cross multiply.
I heard a cross multiply. Let's see here. So this we get 5 times 2x minus 7, right? Equals to x times x minus 2. Very good. Then you got to do what? You got to well,
Distribute.
huh. My cursor is still gone. That's not a good sign. Distribute, yes, that's a good idea. 10x minus 35 equals to x squared minus 2x. All right. Look, what was I just telling you a second ago? Quadratic equations, right? They're inescapable. So, put this in standard form. We've got x squared. Add the 2x, minus 10x over there, so minus 12x plus 35 equals to 0. Can you guys solve that? All right.
Can't you do like
Yeah.
-7 and 5?
very technical fix, yeah. See, I can still take the battery out on my laptop. Not all of you can do that, right? Don't you wish you could sometimes, though? You said, what should I do?
I know like the fastest two would be like 5 and 7, but I think
5 and 7? Okay.
yeah.
I like that. So you're saying we can factor, right?
Yeah.
I believe you are correct. You put a 5 here, put a 7 here. I think we could use some minuses, right? Because we got a minus 12, and minus 5 plus minus 7 is minus 12. Minus 5 times 7, 35, so we got it, right? So this is equal to 0. What does that tell me my solutions are? X equals to 5 or X equals to 7. Now, we have to, whenever we have a problem like this that involves like cross multiplication, you got to be a little bit suspicious. There's a possibility that one or the other of these could have division by 0 in the original problem, but I think if we plug back either one of these answers into the original problem, they're going to work, right? If you plug 5 in, we've got 10 minus 7, which is 3 over 5, right? On the other side, we've got 5 minus 2, which is 3 over 5. 3/5 equals 3/5, we're good, right? You can plug 5 in, it works. Plug 7 in, does it work? 2 times 7 is 14. 14 minus 7 is 7. 7 divided by 7. 7 over 7. We get 1 for the left-hand side, right? Plug in 7 to the other side. We get 7 minus 2, which is 5. 5 over 5. We get 1 for the right-hand side. 1 equals 1. We're good. So here, we have two answers. There they are. Let me continue in my foolish quest to top hat. But while we're waiting for my computer to get a life, let's do example 2. It's a good thing I printed these problems out on this thing we call paper, isn't it? It's almost like I expected the computer to not work someday. Let's see here, 6x over x minus 6 equals to 9 plus 7x squared over x minus 6. Let's see if we can work this one here. All right. So while I'm foolishly wasting more time on my computer logging in again, what do you guys think? What should we do to this problem to make it nicer? Fractions are our mortal enemies. How can we kill them all? I'm sorry, how can we love them until they agree with our viewpoint and we can all live together in harmony? What's that? Multiply? By what? Yeah, multiply by x minus 6. That's a good idea. So let's do that. What happens when we do that? Yeah, so I'm going to sort of, don't tell the other math professors I wrote this, but like this, right? Okay, so that gives me, when I multiply this times the whole equation, cancels, x minus 6 cancels over here. We get 6x. There's no x minus 6 here to cancel, so we get 9 times x minus 6. And the x minus 6 cancels there. So we get 7x squared. All right, come on, you. All right. Fine, I give up. No top hat today. We'll top hat twice next class to make up for it. Don't worry, okay? So, I mean, assuming that one or both of my computers works next time, right? If all my computers break for the semester, you get those points for free. So, isn't that exciting? So, let's see here. So, we have 7x squared, right? Now, that gives me plus 9x, right? Minus 54 minus 6x equals to 0. So what I did was I just multiplied these terms out, right? And I put them first. And then I took this guy and I subtracted it to the other side, all right? Now let's put it in standard form. We've got a 7x squared plus 3x, yeah? Minus 54 equals to 0. Ordinarily, I wouldn't even bother to try to factor this, but since this is a book problem, we probably, you know what I'm going to do though? I'm going to use completing the square because we need more practice on that, okay? Let's use completing the square to solve this equation, okay? So if I'm going to complete the square here, first thing I'm going to do is divide by 7, yeah? So I've got x squared plus 3/7 x minus 54 over 7 equals to 0 over 7, which is just 0. Right? Now I take, and I want to group everything into a square, right? So what we do is parentheses, x, all right, something squared. Now the something there plus what? I need half of the what is half of the coefficient of b here? Here's my coefficient, of x rather. Coefficient of x is 3/7, right? So half of that is, what's half of 3/7?
0.21.
Oh no, 0.21? No. I want a fraction. So I hear you, but 3/14, right? You're going decimal on me. Oh no. Okay, 3/14. Okay. And then to be fair, I have to subtract the square of 3/14, right? So minus 3 over 14 quantity squared minus 54 over 7, right? So that is going to give me, all of that's equal to 0, right? So that's going to give me x plus 3 over 14 quantity squared equals to 9 over, what's 14 squared? 14 times 14, 140 plus 56, 196 is it? I think 14 squared is 196. Yeah, 196. Now, if you see an error in something I've done, please let me know. No, okay. I just glanced at the answer here. It is a little bit ugly. Okay, so then we add those fractions, right? What are those? 9 over 196 plus 54 over 7. It's kind of big. 1521 over 196. Yeah?
I'm a little confused, but I'm not sure.
You're a little confused, but you're not sure where you got confused?
Yeah, like the 196 plus 7, wouldn't you add those up so it wouldn't be 196?
Yeah, no, how did you, I understand how you got from 7 to 14. How did you get 9 over 596?
3/14 squared. So I'll write it here. 3/14 squared, or 3/14 times 3/14 is 3 times 3, which is 9. 14 times 14 is 196. So that's where that came from. So it's the 3/14 squared.
Why did the 54 over 7 turn into positive?
Because we moved it to the right-hand side of the equation. There were minuses before. So we're isolating the square.
Okay.
All right. And So great, then we use the square root property. Square root property says x plus 3/14 is equal to plus or minus the square root of 1521 over 196, which by the way is plus or minus the square root of 1521 divided by 14.
How did you get 196 as the denominator though?
Right here.
Yeah, but like,
I added fractions.
okay, that's all you
I used my calculator,
Okay.
truth be told. I mean, apparently 7 is a factor of 196,
Okay.
right? Let's see here. 196 divided by 7 is 28. So it happens that 28 times 54 plus 9 is 1521, but I thought it would probably be better for me just to use my calculator because it's 815. So, and I think most of you need to use your calculators to add those fractions, right? Yeah, okay, so. Now, is the square root of 1521 something? The square root of 1521 is actually 39. So if this week, if somebody asks you, is 1521 an interesting number, you can be like, it is. It's the square of 39, and then they'll be impressed, you know? Like, wow, how'd you know that? Not something I know off the top of my head, but there it is. Square root of 1521 is 39. And so what we have is x is equal to minus 3 plus or minus 39 over 14. Now, if you want to be fussy, you could write, no, that's fine. Excuse me. It's fine. I mean, now we can do better, right? So this gives us two cases. What are the two cases? X equals to minus 3 plus 39 over 4, right? Or x equals to minus 3 minus 39 over 4. Do those simplify? Yeah, this one's what, 36, right? Over 4 minus 42. Yeah, 42 over 4. Wait, what is that?
You wrote 4 instead of 14.
Oh, yes, I did. Thank you. My bad. I'll fix that. I did it everywhere, didn't I? So, thank you. I think those well, the top one doesn't really simplify much. 36 over 14 simplifies to what? 18/7, because you can factor out a 2. And the other one, hey, what's 42 is 3 times 14, right? So you can cancel 14 here and you just get minus 3. Anyway, this is minus 3. So there you go. There's your two answers here. So hey, the quadratic equation here was a little bit harder to solve. What's another method we could have used to solve this quadratic equation? In fact, I think this is a good example of, I would argue that the difficulty of applying the quadratic formula and the difficulty of completing the square and using the square root property, it's debatable. I think maybe the quadratic formula wins in this problem, right? Maybe the quadratic formula is a better choice for this example. Yeah.
Is there a way to determine which one's going to be better before going through the steps of one or the other?
I think, like, in terms of strategy for solving quadratic equations, my strategy is this. If it factors, let it be. That's the fastest, right? Like this, you can't beat it, right? In example 1, that was wonderful. If you've got numbers that after you isolate x squared make you work with fractions, the quadratic formula might be a good idea, right? But if you have a number which is multiplying the x, which is like even, then completing the square is pretty easy. But we should be ready to use any 3 of these techniques on any problem, right? And sometimes the homework or the quiz will tell you use a particular technique, right? Now this one here, just for logical completeness, if we'd used the quadratic formula on the original problem, right? If I just got to here and I said, oh, well, this is a little bit ugly, I'm going to use quadratic formula, what would that have looked like? It would just looked at like x is equal to b is minus 3, right? Plus or minus the square root of 3 squared, yeah? Minus 4 times a, here a is 7. C is minus 54, right? And I can divide by 2 times a, which was 7, right? So the quadratic formula would have gotten us straight past all this completing the square stuff, right? Straight to the answer. And so I think, I mean, arguably the quadratic formula is a better way to do this one, right? Now, part of the reason this looks easy is we're now a little bit familiar with these numbers. That is, I believe, 1521, yeah? So I just knew that because of what we just did. Otherwise, I had to plug it into my calculator and suffer through it, right? Did I mention to you guys that the well, not TI, but this Casio has a built-in equation solver? Did I tell you last time? Okay, cool. Anyway, so either way. And of course, that simplifies to 18/7 and minus 3. So, yeah, go for it.
So on the quizzes, are you going to have like questions that involve showing or like completing the square?
Yes.
Like that?
Yes, there will be a problem on the quiz that asks you to complete the square and show your work completing the square. I do.
To that extent, to where
It,
it
it,
would be easier to do it.
it could be to this extent, but it probably wouldn't be with numbers this ugly. You know, I'd probably pick something that involved like thirds or sixths or ninths and not 1521. You know, I want something, ideally, if I'm going to have something with fractions on the quiz that tests completing the square, I want the fractions to be small enough that it's conceivable that someone who was taught multiplication tables and has a good sense of like basic arithmetic could suffer through it without picking up a calculator. That would be my ideal problem. Or, I mean, more likely, the completing the square problem, I would just make it so that it works out nicer. Something like, just so you have a sense of what I'm talking about. If we had something like, oh, I don't know, 2x squared plus 4x minus, I don't know, 17 equal to 0. We could solve that with completing the square. It wouldn't be as bad. So like, step 1, I divide by 2, you know. I mean, it's got some fractions in it, but it's not too bad. Complete the square here. X plus 1 squared minus 1 minus 17 over 2, which gives me 1 plus 17 halves. And I think most of us probably can figure out, you know, 1 plus 17 halves without picking up a calculator. Maybe. 1 is 2 over 2, right? So 17 halves plus 1 is 19 halves, right? And so, square root property, right, gives me x plus 1 equals to plus or minus the square root of 19 over 2. Funny. Okay, and then, so there you go. Answer is x equals to minus 1 plus or minus the square root of 19 over 2. So there's completing the square that involves fractions that's not so heinous like this one, right? Yeah. But I do want you to learn all of the methods we've talked about, even the factoring with completing the square like I did at the start. I haven't really gone back to that because I think this method of isolating the square and using the square root property is easier for actually solving problems. But if we wanted to factor this, right, we could also factor. How would factoring this look like? Could you factor this? You'd have x plus 1 squared, right, minus the square root of 19 over 2 squared equals to 0, right? So you could factor this as x plus 1 plus the square root of 19 over 2, x plus 1 minus the square root of 19 over 2. So there's also that, which I haven't really circled back too much since we first did it. That's really more interesting just for the problem of factoring. Like if the problem is solving the equation, I don't think that algebra is super helpful, but if you have to factor this, you know, completing the square paired with factoring is really the way to go, because that's what I did here, you know. But anyway. Let me move along here. Let's look at the next one. Next up, we have x minus the square root of 15 minus 2x equals to 0. This will be a rerun for the people in the other sections watching this video. See, they're all watching your class tomorrow because I won't be here tomorrow, right? I'm going to Alabama, sell a house, I hope. All right. Otherwise, we're just going to Alabama to visit our friends, which is not bad, but then I'm just going to have to go back to sell the house another day. Which I guess wouldn't be too bad, but anyway, here we go. So we isolate. So I asked the other classes, how do you, if you're the government and like there's unrest in the streets, what should you do? Any of you planning a career in government? Huh, good people. Okay, so I'm just kidding. We need good people in government, right? Someday. We should isolate the radical, right? That's what you want to do. If you got protests, you need to isolate the radicals, right? So if we isolate the radical, this is what that looks like, right? Isolate the radical. And then if you want to get radicals, what do? You want to turn them into a square, right? I was telling the other sections that joke is about 40 years too late. But see, I'll have to explain it now, which makes it not a joke, right? So we used to call people who were part of the establishment who followed the rules, they were squares. And usually you would follow that with a parenthetical man. Squares, man. Anyway, so we squared it. Now everything's a square. Of course, that's the natural thing to do because that will get rid of the square root. And we get 15 minus 2x. Aha! You're like, goodness gracious, every story ends with the same thing here. Yes, all of these problems pretty much will end with a quadratic. That's why they're in right after the quadratic section. So here we have x squared plus 2x minus 15 equals to 0. Going back to our previous discussion, now you're in the driver's seat. What's the right method? Quadratic formula, completing the square, factoring. Factoring. I like it. We've got x. We've got x. All the x's you need. How many? We got 15, right? 15 is what? 5 times 3? Ooh, how about a 5 here and a 3 here? You give me the signs. Ah, I saw the sign. It's good. Thank you. Plus 5 minus 3. Better not forget my equals 0. That's kind of important. So the solutions are apparently minus 5 and 3. Now I say apparently, right? Because with this kind of problem, you have to go back to the start and check. That was also true of my previous problem. I should have checked those numbers, plug them back in, but now it's erased. So the 8/3 and the, oh, that's unpleasant. Pretty much with this problem, the only thing that's going to get you into trouble is 6. All right? Did you have a 6 in your solution? No, you're probably okay. How about this one, though? Let's try checking our answers. So check the answers. Check it. All right, so we got minus 5 minus the square root of 15 minus 2 times minus 5, right? And on the other hand, we've got 3 minus the square root of 15 minus 2 times 3. So what I'm doing is I'm plugging my alleged answers back into the original problem and seeing if this algebra we did worked. Did it? How about this first one? Minus 5, what's 5 times 2 with minus canceling gives me 10. 10 plus 15, 25. Square root of 25, 5. So this one is actually minus 10. This, of course, is not equal to 0, right? So that fails. On the other hand, we've got 3 minus the square root of 9. 3 minus 3, it's 0. Woohoo! So in retrospect, after we check, we found out that, what we find out? Only the 3 is the actual answer, all right? This right here is an extraneous solution. Did I ever tell you guys my plans if I was to engage in a career in rap music? No. So if I was to do such a thing, I would be known as extraneous G. And then my tagline would be, I'm not even in the solution set. See, all my songs, you'd hear that I'm not even in the solution set. It would be every song. And this is what that would be about. So there are high school math professors teachers, I guess, I don't know, depending on your school, who spend an inordinate amount of time putting together videos of various math things, and they're all very sad. So I don't want to do that. It would also be sad. Although there are certain acts of mathematical bravery mixed with music which are worth forcing math majors to watch, but I wouldn't do it to you guys. I wouldn't do it to you guys. I feel like I've found a good video if after watching the video the students say something along the lines of, I can't unsee that. I feel like I've done my job if that happens. So if you guys do too bad on the first test, there's a video I'm going to make you watch. Just saying. So make sure you guys pass the first test. Let's see here, 2x minus x plus 4 equal to 0. Let's see if we can solve this one, all right? All right. Okay, so isolate the radical. X minus 4, right? Now, once we isolate the radical, next step, eliminate the radical, right, by squaring. So we square both sides. Be careful when you square. Standard mistake students make here is they square it and they don't think through the multiplication, right? Very popular mistake here. Students just write x squared plus 16. And they forget that there's also a minus 4x and a minus 4x, right? Because x minus 4 squared, what does it mean? X minus 4 times x minus 4, right? So if you FOIL that out, there is a middle minus 8x term you must not ignore, right? That's there. You have to face it. And on the other hand, we just get 2x. So when you square the equation, think through it. You have to multiply it out, okay? Now, this is going to give me x squared minus, looks like a 10x plus 16 equals to 0. How do I think we can factor this again, right? What'd you guys get? What'd you guys get? X minus 2, x minus 8. I think we have a winner. So the answer is either 2 or 8. But then the question is it? Right, so now we have to check those answers. So we check x equals to 2. I've got square root of 2 times 2 minus 2 plus 4 right? So square root of 2 times 2, that's square root of 4. Square root of 4 is 2. 2 minus 2, 0. 0 plus 4 is 4, which is, by the way, not equal to 0. Oops, extraneous. X equals to 8. We've got the square root of 2 times 8 minus 8 plus 4, which is the square root of 16. The square root of 16 is 4. So here we've got 4 minus 8 plus 4, also known as 0. So there you go. Our only solution here is 8. Why do we keep getting extra solutions? How's this happening to us? Do you guys know? What's the offending step? Where did we add solutions to the solution set? Like if you're dealing with an equation, you multiply by 1, right? Or you add 0. That's not going to usually change, I mean, without doing something really funky. It's not going to change the solution set. But there is something. If we square the equation, right? This step right here where we square the equation, what that does is it erases minuses. So if you think about it, if instead of this equation, we had come to this problem with the following, if we had like the square root of 2x equals to 4 minus x instead, if you square that equation, it also goes right to here. So probably the extraneous solution, 2, is a solution to the corresponding like negative equation. So if I plug 2 into this, I get the square root of 2 times 2, which is square root of 4, which is 2. And here I get 4 minus 2, which is 2. 2 equals 2. So this actually solves this corresponding equation where the right-hand side was minus what it was. So that's where this is coming from. It's not that there's something wrong with the algebra. It's just that one of the steps we do, it brings new members into the family, so to speak. I mean, it increases our solution set sometimes. Not always, but often in these problems. So it's not that we're like somehow solving the quadratic equation wrong or something like that, or half right. The quadratic equation, we solved it perfectly correctly. It's just that when we square the equation, we added things. All right, so next example here. Now this one is a little bit different pattern. Here we've got square root of x minus the square root of x minus 45 equal to 3. How are we gonna attack this one here? Just making sure my thing's working. So again, you want to isolate the radical. The trouble is now we got 2 of them, right? So the question is, which one do you want to keep writing? Which one is more annoying to write? I think the square root of x minus 3 is more annoying, right? So you get rid of that one first. So isolate this x minus 3, x minus 45. Okay, so the square root of x minus 45 is equal to the square root of x minus 3, right? So I just rearrange the equation a bit. All right. And now square both sides. Right. Again, we need to think through the squaring. The left-hand side is easy, x minus 45. The right-hand side, we're going to have the square root of x, quantity squared, minus 6 times the square root of x, right? Plus 9. Let me erase the other one so I can write that out. So like, what's going on here? Remember what this means. Right, so when you multiply that out, you have the square root of x squared. You have 2 copies of minus 3 root x, which gives you 6 root x minus, right? And then 3 times 3 is 9. Of course, this simplifies a bit, right? So what we really have here is x minus 45 equals to x minus 6 square root of x plus 9. Oh, look at that. That's nice, right? See that? That's real nice. This and that cancel. Yay. So now we just have square root of x left, right? So let's isolate square root of x. We get, I'm going to add that to the other side. I get 6 root x is equal to 9 plus 45. 9 plus 45 is, what, 54? That's kind of a cool pattern. Now divide by 6, right? Square root of x equals to 54 over 6, which I believe is 9, right? Yeah, so that's 9. Now, again, square both sides, right? So, oops, square root of x squared equals 9 squared, which gives me x is equal to 81. What's the solution set here, by the way? Your book asks what's the solution set. So solution set is what? It is the set containing 81. Okay, great. Solution set. All right. And I guess since we squared this problem, we should probably check it, right? If you plug 81 back into here, you get square root of 81, which is 9. 81 minus 45, what's that? $36, yeah? So 9 minus the square root of 36, which is 6. So 9 minus 6 is 3. We have a winner. All right, you can check it. It's all good. Let us do another.
This would still work if you isolated the other route, correct?
Oh yeah, yeah. It wouldn't matter. I think this makes the algebra look a little bit easier, but it's all good. Here we got the square root of 2. Oh, fine, I'll do the other one. Let me make sure. I gotta check on time here. I better. There are 2 problems kind of like this in your homework. It is possible for these to work out. Well, I better do the other one. Fine. I'm debating whether or not I have time. All right, equals to square root of 7x plus 4 minus 2. All right, so again, the question is, do you just want to square it as it's given to you? I mean, we could do that, right? Here, I'll do it. I'll just square it and see what happens. Take this equation, square it. What do you get? We get 5x on this side. Square root of 7x plus 4 quantity squared minus 4 square root of 7x plus 4 plus 4. So again, that's because this is the square root of 7x plus 4 minus 2 times the same thing again, yeah? Hopefully I'm still in frame, I don't know. I'm on the edge of things here. Yeah, we're okay. So when you FOIL this out, you get this. You get 2 copies of the cross term. I mean, you get minus 2 of the root, minus 2 of the root. So minus 4 of the root, and then minus 2 times minus 2 is plus 4. All right, let's clean it up. We've got 5x equals to 7x plus 4 minus 4 times the square root of 7x plus 4 plus 4. Now I have to isolate the radical again, okay? So this gives me, I'm going to add that to the other side. I get 4 square root of 7x plus 4 equal to, so moving the 5x to the other side, 7 minus 5 is 2x. And I got a 4 plus a 4, right? Which is an 8. Again, I think it would have been smarter to isolate the square root of 7x plus 4 here as our initial step. But I want to show you, you don't, I mean, whatever you do, if you follow the policy of squaring to eliminate one of the radicals, you multiply it out, you'll get another radical in the expression, then you isolate that and square again. It'll still work out. It could be uglier one way than the other. Now here, you could divide by 4, right? You could do that. But let me just go ahead and square the equation. All right? Just to be lazy, maybe you should divide by 2. I don't know. If I square 4, I get 16 and 7x plus 4. So I have to square the 4 to get 16. I square the square root to get the thing inside the square root. And over here, you got yourself a 4x squared plus 16x, which is 32x, plus 64. At this point, I mean, just divide by 4 already, right? Divide by 4, right? If we divide this whole thing by 4, life will be a little bit easier in the next step. So we get 4 times 7x plus 4 equals to x squared plus 8x plus, what's 64 before? I believe it's 16, right? So this guy is what? This is 28x plus 16. So we simplify that, what does it get us to? So like we can think about this 16 canceling that 16, right? And so what we get is x squared. What's 8 minus 28? It's minus 20x, right? And this one here, we haven't run into this example too much, but it's an important one. We just factor x out, right? So here the factoring's even easier. Just factor x out, and lo and behold, we find the answers. X equals to 0, or x equals to 20. It turns out, if you plug those back into the original problem, they both work. Right? So you go back up here, plug in 0. 0 is equal to the square root of 4 minus 2, which is 2 minus 2. 0 equals 0. It works. If you plug in 20, you get the square root of 100, which is 10. On the other side, you get the square root of 144, which is the square root of 144, which is 12. 12 minus 2 is also 10. 10 equals 10. It also checks. Yeah. So sometimes when there's 2 square roots, you get 2 answers, right? And sometimes, see this right here, this was very nice, what happened back here, because that's what kept us from having to work the quadratic equation at the end of it, yeah? So these problems, they can look very similar, but have a different flow in the solution, yeah? That's what I'm trying to tell you. Example 8. An interesting question to ask is why are these problems so different even though they look the same? Like what's going on? How to understand the different cases which are appearing here. And for me, the answer to that question comes when we study graphing equations, right? And we're not doing that yet, so I can't really explain. But we'll explain later, graphically. How do you solve this? I mean, I think we're just going to square it. Square both sides. Which will get me to 2 square root of 5x plus 5 equal to 2x plus 2. You might wonder, why do some of my 2's look like this and other of my 2's look like that? I have no good answer for that. But I can just tell you that it's what I do. So there you go. Is that better for you? If any of you are suffering from the incongruity of my handwriting. Now, if you divide this by 2, we got what? I think dividing by 2 is a good idea, right? Let's clean up the mess before we take the next step. And then what do? How about, again, square? Again, when you square out this, we have to think about foiling it out, right? X plus 1 squared is x plus 1 times x plus 1, right? Which means what we have here is 5x plus 5 equals to x squared plus 2x plus 1. Well, look at that. Another quadratic equation. So we've got x squared minus 3x minus 4 equals to 0. Put everything to one side. Basically, I subtracted 5x and 5 over to the right-hand side here. Can you guys solve this one? Do, 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 do. Do, 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 do. I've got a vote for x minus 4 times x plus 1. I think we have a winner. And so that gives us solutions of 4 or minus 1, right? Again, since squaring was involved, I got to be suspicious of these answers. We need to check. Do they work, right? So since I've got room this time, I'll write it out. X equals to 4. Let's check our answers. We've got square root of 2 times the square root of 5 times 4 plus 5. Right? Is that equal to, question mark, the square root of 2 times 4 plus 2? So that's 20 plus 5, which is 25. The square root of 25 is 5. 2 times 5 is square root of 10. And on the other side, we've got the square root of 10. So, yay, 4 is indeed a solution. How about minus 1? We have square root of 2 times the square root of 5 times minus 1 plus 5. Is that equal to, question mark, the square root of 2 times minus 1 plus 2, yeah? I mean, 5 minus 5 is 0, so we've got the square root of 0 here. Is it equal to the square root of 0 there? It is. The square root of 0 is 0. 0 equals 0. We have a winner. So here, the solution set has 2 things in it. 4 or minus 1. All right. So like I said, squaring the equation can add solutions, but it doesn't have to. Aha. So now we're graduating from square roots to cube roots. What is a cube root? Actually, let me pause my example and just remind you of property. Or definition, depending on how you want to look at it. A to the 1 over n is equal to the nth root of a, right? And fun fact, if we take the nth root of a and we raise it to the n power, we get a back again, right? Caution though, if we take the nth root of a to the n, they're cases, right? It's just going to give you a again if n odd, whereas it gives you the absolute value of a if n is even. As an application, like the cube root of x cubed, it's just x. But the square root of x squared is absolute value of x. And that's why when we take the square root, we have to put the plus minus. See, because absolute value of x is plus or minus x, depending on whether x is positive or negative, yeah? So there you go, just a reminder about exponential versus radical notation, right? And you know, there are laws of exponents and so forth we could talk about, but let us move along here. Example, oh man, I lost my number. Can you guys tell me what it was? 9. Am I on 10 then? Or this is 9, okay. Thank you guys. Okay, so if we got the cube root of 2x minus 8 equal to the cube root of 5x plus 28, this is a kind of silly problem. What do? You just cube both sides, right? In so doing, you get 2x minus 8 equals to 5x plus 28. Oh, this is even easier than quadratic, right? So we've got 3x plus 36 equals to 0, I believe. So I subtracted 2x and added 8 to both sides. And then, of course, if you solve, you got 3x equals to minus 36, which gives me x is equal to minus 36 over 3. X equals to minus 12. And if you plug this equation, if you plug the solution back into the original problem, it works in the sense that you can check it out. If we plug in x equals to minus 12 into our original problem, we get the cube root of 2 times minus 12 minus 8 equals to the cube root of 5 times minus 12 plus 28. Right? Which is the cube root of minus 32 equals to the cube root of minus 60 plus 28, which is also minus 32. Now, you might be wondering, but is that a complex solution? Well, the answer is no, right? The cube root of a negative number is a real number. For example, just to do something more concrete, the cube root of like minus 8 is equal to minus 2. See, because minus 2 cubed is equal to minus 8. So cube root of a negative number is not imaginary. It's the square root or the fourth root of a negative number, or even roots, that will get you imaginary numbers, okay? Although I won't ask you.